Hello, everyone. Welcome to the first sort of review thing that we're doing here on our channel. It's going to be a 30-minute lesson. I'm just going to give it a couple minutes before I go ahead and get started. But for everyone who is here, though, this review is going to be a review of Lesson 7. So that's the lesson that we did yesterday on Saturday. So how is everyone doing? Taking care? What's going on? I'll give it one more minute, and then we'll go ahead and get started. Hey, Maria, how are you doing? I know, it's like our first sort of review thing. Should be pretty fun. It's only 30 minutes long, so it'll go by pretty quick. I mean, our normal lessons go by quick in my opinion, so this should be like, you know. Actually, you know what? I'm just going to go ahead and get started. Let's not waste any time because we honestly don't have that much in the first place. The first thing I want to talk about before I go ahead with the review is yesterday I went on this site called practicepython.org. Now, this is a great site for, beginner exercises and stuff like that. So if you're looking for some extra practice outside of what we're covering in the lessons, then this is definitely the place to go. Some of this stuff may be outside of the scope of what we're going to learn, but it's still worth going through them because the sort of author of these exercises talks about different things that you can use Python for. So like this in keyword, right? We were just talking about that yesterday. And you can also find, people's solutions, and you can read other people's codes. And it's really a great way to just see how other people approach a problem. And it's a great website in general. So with that out of the way, let's go ahead and get started with a review of Lesson 7. So Lesson 7 was actually, we didn't really cover that much stuff. We mostly did a review of Lesson 6. And I'm actually not going to touch on anything we did in Lesson 6 because you can just go ahead and watch Lesson 7. But the things we did talk about in Lesson 7 that were new, the first thing we talked about was this in keyword, the in keyword. Now, this in keyword, so I'm just going to create a sample list actually. Again, I'm going to go with a trusted grocery list example. We'll say fruit, what else? Cereal, milk, right? We'll just leave it with 3 items for now. We have our grocery list, and our in keyword is basically a way for us to check to see if a specific item is in our list. So, and that actually yields or it actually returns a sort of Boolean value that's either true or false. I'm going to go ahead, I'm going to open up a print statement. And in this print statement, I'm just going to put a simple expression, right? And this expression will end up, simplifying into either a true or a false. So my first expression, I'm going to say fruit in grocery list. So this is my expression. So this is sort of the main thing that we're looking at. And within this, you notice I have fruit, I have in grocery list. And this reads just like plain English. It's literally asking, is this string fruit within the grocery list? And if I look within my list, you'll see fruit is right here. So when I run this, I should hope to see true. So that's how that in keyword works. Now you can also use this in keyword. It's also used in tandem with the not keyword. So if you remember our truth tables, you know that not takes a Boolean value and then flips that. So if I have true and then I put a not in front of it, it's going to make that false, right? So if something's not true, then it's obviously false. If something's not false, then it's obviously true. So how can the not keyword be used with it? So for this, I'm going to say ice, right? So if I say ice in grocery list, grocery list, we know that this first thing will give us true. But ice in grocery list, do I see the string ice anywhere within my grocery list? No. So if I run this, I get false. However, if I put a not right here, right, ice not in grocery list, and I run that, then I get true. And again, this in keyword is actually amazing because it reads just like normal English. Ice is not in grocery list. Well, that's true. I don't see ice anywhere within my grocery list. So that is our in keyword. And yesterday I had a question asked about when this is like most commonly used. And I said that it's mostly used within if statements, right? When you have this expression that your if statement either decides is true or false, and if it's true, it'll do something, then that's when that in will be used. So if I copy this, right, and I paste this, if I say if fruit in grocery list, I'll say print you have fruit in your grocery list. Else, print you do not have fruit in your grocery list. Oops, list. So if I run this, it says you have fruit in your grocery list. Why does it say that? Well, we have our list, right? That's the first thing Python sees. Then when we come here to this if statement, it's going to check this expression right here. It's going to say, is fruit within my grocery list? Well, yeah, it's right here. So that means this whole statement will evaluate to being true. And because this is true, it'll print out our print statement right here. So if I go ahead and remove fruit from my list, however, right, and I run this, then it says you do not have fruit in your grocery list, right? Why does it say that? I'm making my list. When it comes to this if statement right here, it says fruit in grocery list. Well, I don't see fruit anywhere in my grocery list. So this whole thing will become false. False. And actually, let me turn off my Google Chrome. Hopefully that'll stop it from popping up. Or not Google Chrome, Google Translate, sorry. So it's going to say, since this is false now, it's not going to run this whole print statement right here. And it's going to default to our else and print out you do not have any fruit in your grocery list. So there we go. So that's our in keyword, how it's used, and how it's used within the scope of, say, our for loops, or sorry, our if statements. The next thing we talked about after we went over our for loops is sort of a different way of iterating over a list. So going through the items in a list individually. And this thing that we actually covered was actually one of the most important things that we covered. So I'm actually going to go ahead and instead of using the grocery list example, I'll use the class roster list example. We'll have Janice, we'll have David, we'll have Edward. These seems to be the most common names I have in my head. So if we wanted to print out all of these names individually, what we would usually do is we would create our for I in range, whatever, right? And we would use this as our foundation. We'd have for I in range, and then we use our length function, right? Because that gives us the length of our class roster list. It's going to print out I. So if I do that, I get 0, 1, 2. And we know that we use our I, right? Because I has a different value each time. We use it as our index to retrieve specific values. If I do class roster I, you'll see I get Janice, David, Edward. So this is how we, last time at least, we used our for loops to go over all the items within a list. This time, we showed how instead of having to create a series of numbers and then using those numbers as indices to pull specific values, we could just directly pull and interact with those values. And it was very simple. So we had something like name in class roster, print name. You see both of these do the exact same thing. So the top three right here, that belongs to this for loop. The bottom three right here, that belongs to this for loop. So what is this for loop structure doing? Well, it's doing basically the exact same thing as this, but you'll see with this, I'm creating a series of numbers, right? 0, 1, 2. I'm using that number as an index, to then pull that value. However, with this, for name in class roster, it's directly pulling Janice, directly pulling David, directly pulling Edward. And on each turn, it's saving it to the variable called name. So this is actually a much easier way of interacting with our lists. So actually, let's do a little project with this, right? I'm pretty sure yesterday we had a list of sort of like test scores, right? Test scores, and I just put a bunch of random numbers in here. Someone got a 89, someone got a 78, someone got a, I don't know, a 60, someone got a, keep them as realistic as possible, 92. It seems like a good distribution. So we have our list of test scores, right? And these are all integers. So first, let's start off with what we know. And what we know is we're going to create, actually, let's talk about what I want to do with this little project. I want to make a program that takes a list, and then saves all the scores that are greater than, we'll say, 80 to another list. Okay, so make a program that takes a list, so that's this list right here, and then saves all the scores that are greater than 80 to another list. So we're basically going to have our code go through each item in this list. It's going to say, hey, is this greater than 80? If it is, then we're going to add it on to another list. If it's not, then we're just going to leave it. So we're going to create another empty list, right? We're going to call this scores above 80, right? And that's our empty list right there that we're going to move our items into. So let's go ahead and create our general structure, right? We have for score in test scores. Right? And again, I'm naming this a variable name that sort of makes sense within the scope of what I'm doing. So with the class roster, it was name. With this, it's going to be scores. It just makes sense. For every score that's in my test scores list, do something with the score. So for score in test scores, let's just start by printing out that score. And seeing everything, making sure it works. Awesome. So we get 100, 89, 78, 60, 92. Bingo. So now what we're going to do is we're going to have an if statement. Okay, we're going to say if that score is above 80, right? So if it's above 80, then we're going to go through and we're going to add it scores above 80 dot append that score. Cool. So what's happening here? Basically, my code is going to go through all of the scores, right? One by one. It's going to check to see if that score is above 80. If that score is above 80, right? If this ends up being true, then it's going to come down here and it's going to add it to my scores above 80 list. It's going to add it to this list right here. And I'm doing that with my dot append. So if my score is above 80, then it's going to add it to my scores above 80 list. If it's not, then nothing's going to happen. So I really only have to specify this right here. Why score? We're talking about which line? 6. Why score and not just dot append? Oh, so remember, with my dot append, I have to, okay, so this right here is the name of my empty list, right? Dot append is that, remember, it's that method. If you remember, a method is sort of like a function that is only able to work with specific items. So in plain English, what this is going to say is, hey, Python, take my scores above 80 list, and what I want you to do is I want you to add to that list whatever the score is that's above 80. So in order, I have to put score here so that Python knows what value I'm actually adding into my list. So now that we have that, we can then come here and then we just print out scores above 80. Scores above 80. If I do that, see, it prints out all of my scores which are above 80. So I have 100, that's above 80, 89, and 92. So 78 and 60, they're both less than 80, so they're not going to be added into my list. So that's a little review of our for loops, our lists, and how we can use them. The last thing I talked about yesterday was something called a tuple. And I went over this really quickly because I really didn't think it was super duper important. And I still don't think so. But it's always good to know these things. So tuple is sort of like a list, but you can't change it. And in Python, when you can't change something, not in Python, but just programming in general, when you can't change something, it's called immutable. Immutable. If you look at the word immutable, im means not, mutable means able to change. So not able to change. And again, this is a word that actually you should know. Immutable. You'll see it used in other languages. So what sets apart a tuple from a list, other than the fact that it's immutable? Well, it's also how you make a tuple. So I'm going to compare them side by side. And I did this yesterday, but a little review doesn't hurt. So we'll have a class roster list. We'll have a class roster tuple. My list, you guys already know, brackets, right? I'll put my names in there. I'll just put one name in there. I'll put David in there. My tuple, on the other hand, doesn't make use of brackets, but it makes use of parentheses. And then I put my item in there. However, you'll note that I've only put one item in here. So if I run this as it is, Python will just say that, hey, this is just a string, right? Because remember, we use parentheses to group things usually. So in order for Python to actually know that this is a tuple, I'm going to add a comma right here. Why am I adding that comma right there? Well, with a list, right? Again, this is only when you have single items, when there's only one item within my little data container. Python knows that this is a list because of these brackets. But with these parentheses, again, we've used them with our if statements, we've used them with our print statements to group things together. So in order for Python to know you're not just trying to group a string, right? You have to add that comma there so it knows that, hey, this is a tuple because tuples can have multiple values. And I'll talk a little bit more about that later. So we have that, right? And let's just try to change my list. How can I change my list? Well, I'm just going to go ahead and change this first value right here to Edward. And if we run this, right, we print class roster list, you'll note that it works, right? We've changed David to Edward in my class roster list. But if I try to do the same thing with my tuple, right, you'll note that we get an error. And it's going to say, tuple object does not support item assignment. Why? Because tuples are immutable. Now, I talked about this yesterday again, and I raised the question, why would people use tuples in the first place, right? Lists are so much better. If you don't want to change a list, then just don't change it. So the fact that a tuple can't be changed makes it a little bit faster when Python is doing computations and stuff with it. And again, that's sort of an issue when you're at a higher level of programming and speed actually matters. So that's why tuples might make more sense. If you actually have data that there's no need for it to change, you'd make it a tuple so that Python is able to run it a little bit faster. But again, that's sort of out of the scope of what we're trying to explore here. So when you think tuple, think list, but you just can't change it. That's sort of the way to look at it. And we've actually gone ahead and reviewed everything that we talked about yesterday. So since you guys decided to be here, I'm going to introduce something a little new. I sort of want to use these review days as like a time to introduce some cooler things that aren't really a part of the main sort of curriculum that I want to touch upon. So this is sort of like a treat. So this, I'm not going to talk about it in the main lessons. I'm just going to save it because it's really quick and it's actually sort of interesting to look at. We're going to talk about something. We're going to talk about another function called the type function. Right, so we've talked about our int, float, str, input, range, length. So we're going to add one more. It's called our type function. And what our type function does is you give it an argument, and it tells you if it's a string, it tells you if it's a tuple, it tells you if it's a list. And while that might not seem super useful because those are things that we can identify by ourselves, it's just something to have in case you're exploring a variable or something like that. And again, this is just sort of like a quick thing. I just want to talk about it because it's pretty useful, and I just want to pass the time. So I'm going to create a bunch of variables. My string is equal to this. My integer is equal to 10. My float is equal to 3.14. I'm just creating a bunch of different data types. My Boolean is equal to true. My list is equal to this. My tuple is equal to, and I should put an item here so it doesn't get confusing. Okay, so I have all these different data types and data containers, right? How can I use my type function with them? I'm just going to go ahead and do print type my string. You'll see it prints out class str. So that tells us that it's a string. And if I copy this and I paste it, I just replace this with my integer, my float, my Boolean, my list, and my tuple. Wow, this Google Translate thing is kind of annoying. Looks like a REPL lost connection. So what this is going to do is it's going to print out what everything is. So you see str, int, this is a float, this is a Boolean, this is a list, this is a tuple. And it's just a cool function. Say if you're looking at some code and you need to check to see if something's a string, or you check to see if it's a float, then you can use the type function to help you out with that. So again, that's a type function, really plain, really simple. It's really just used for, exploring variables so you know what you're working with. So that's one of the cool things that I wanted to look at. The last thing I wanted to talk about, and I'm going to talk about this in the main lesson a little bit later on. I just want to expose you guys to right now because I think it's pretty cool, and I think it, if you guys are working on your own code, that it would help you out. Is something called the new line character. New line character. So you remember, if you ever been sort of like printing a bunch of things out to your console, right? So print my name is Varun. It's gonna print this a bunch of times. Let's just say you have a bunch of print statements, right? It doesn't necessarily have to be the same thing over and over. It can get kind of cluttered, right? Kind of hard to read all that. So the new line character is exactly what it says it is. It basically just creates a new line. So that between my Varun is, or my name is Varun, it'll have like a new line or empty line. And so to have a new line character, what you just do is you have this /n. Oops, yeah, like that. So if I run this, see, I now have a space right here. It's a new line character. So when it prints this right here, it's going to print this empty space like that. And you can chain them together, right? You can put a bunch there and then it'll be a bunch of space. So let's say you're just trying to make a game or something and you want to make your code look a little bit fancier, a little bit more organized. Then the new line character is the way to do it. And I'll touch upon that a little bit later on when we're working on more projects, but I just thought it was cool and I wanted to share it with you guys. So yeah, that actually wraps up our review lesson for lesson 7. It was really quick and I'm actually glad we did it because that means that's going to save us like 30 minutes when we start lesson 8. So any questions, anything? Because I know it was kind of fast. Frankly, I was a little bit unorganized with this one. So any questions? Hopefully this whole type function and the new line character are able to make any of the code you guys are working with more interesting. Can you re-explain this new line character? Okay. So when I have a bunch of print statements, right? I'm just trying to create like a scenario to show why it might be used. Let's just say like it's a bunch of these, right? It could get kind of cluttered and hard to look at, right? Kind of hard to separate each of the lines from each other. So you can use a new line character. It's sort of like when you're typing into, actually, I can just demonstrate it right here. Let's just say I'm typing something, right? My name is Varun. If I want to go to the next line, right, I press enter. And let's say I want to leave this line blank, then I can press enter again. So think of a new line as a way to press enter, but like within your code. So if you're making a game or something and you want to space out all your different things that you're printing out, then you can use a new line character. And it looks just like you got the slash and you have the slash n. And it's just used to add an extra line. And I'm putting it at the end of these print statements because, again, you want to print all of these out and then you want to put the new line. But say let me get rid of this. Say I took my new line and I just put it in the middle right here. That's going to print my name is. It's going to put a new line, and then it's going to print all of this. So it's like sort of pressing enter. So like think of Python typing this whole thing out. It's going to say my name. I see that new line. It's going to press enter. And it's going to print out the rest of this. So it's a space, a tab, a space is Varun. That's sort of what is being printed out to our console. So think of it as just a way to manipulate how things are being printed out to the console. And again, it's just one of those cool things that I wanted to share. So yeah, any other questions? Any other concerns? Because if not, I mean, I think that was a pretty successful first review. Awesome. Not for me. Good to hear. Well then, our next lesson will be lesson 8, and that'll be Saturday at 12 p.m. Eastern Standard Time. So the same thing that we did yesterday. And so it's going to be a lot more regular how we do our streams every Saturday and Sunday. And then I'll have the review the day after. So things are looking good. You guys are doing great. So that wraps it up. So be sure to take care of yourselves. Keep practicing, right? PracticePython.org. That's the place to check out. So take care of yourselves. Be safe. Do well. And I'll see you guys in the next lesson.